Hello students, today's chemistry class is on the topic oxidation number and Iupac name of inorganic compounds. Oxidation number and Iupac name of inorganic compounds. The abbreviation Iupac stands for International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. Inorganic compounds are compounds that do not contain carbon. Inorganic compounds are compounds that do not contain carbon. On the board are some examples of inorganic compounds. K2CrO4 is an inorganic compound. We're asked to find the oxidation number of chromium in this compound. Oxidation number is the same thing as charge. So we're asked to find the charge which this element here carries. We'll start by saying let the oxidation number of chromium in K2CrO4, let it be, let's say X. We are stating let the oxidation number of chromium in this compound be X. Okay? So we are going to sum the oxidation numbers of all the elements here. Do you remember potassium? Do you remember the group in the model periodic table to which potassium belongs? It is in group 1. And you have been taught that elements in group 1 are usually metals. During chemical bonding, they lose their valence electron. So if potassium, atomic number 19, has electron configuration 2881, during chemical bonding, it's going to lose this one electron. When it loses it, what charge is it going to have now? It's going to have a charge of plus. That is plus 1. Do you understand? So I'm going to, talking about potassium now, I'm going to write plus 1 times, how many atoms of potassium do we have here? 2 atoms, so I'm going to say times 2. Plus, the next element, what element is that? The next element here is chromium. And is the oxidation number of chromium that we are assuming to be X. Do we have more than 1 atom of chromium? No. So the X will remain 1. Then we'll go to oxygen. What is the oxidation number of oxygen in its usual elements, in its usual compounds? Oxygen is element number 8 in the modern periodic table. That means it has electron configuration 2,6. Do you understand? 6 electrons in the outermost shell. Is it a stable electron configuration? No. It's going to gain. How many electrons will it gain to make it a stable electron configuration? 2. So when it gains 2 electrons from an element, usually a metal, into the outermost shell, how many electrons will it now have outside here? 8. And so what charge is it going to have? When we have plus 8 minus 10. The 10 is 2 here plus 6. How many? 8. Plus the 2 electrons it gains. How many? 10 electrons. So plus 8, which is for protons here, minus 10. What are we going to have? Do you remember number line in your JSS 1? Using the number line, plus 8 minus 10 equals minus 2. That is, you have 8 naira, but you are owing somebody 10 naira. Can you pay off all the money you're owing? No, you can pay 8 naira. You are still owing how much? 2 naira. So the minus 2 means you are still owing 2. That's the charge of oxygen in this compound. So we have minus 2 times, how many atoms of oxygen do we have here? 4 atoms, so times 4 equals, what is the net charge? What is the overall charge of this compound here? 0. the net charge of compounds is usually 0. Okay, so let's continue. Plus 1 times 2 gives us plus 2. You bring down plus x. Minus 2 times 4, minus 8. Minus 8 times plus, it gives us minus 8 equals 0. Are there like terms? What are the like terms? Plus 2 and minus 8. Can we put them together? Yes. So plus 2 minus 8. What are we going to have? Minus 6. You bring down this x here. X minus 6 equals 0. The next step is to carry this minus 6 all over to the right hand side. So you have x equals, you bring this minus 6 here, it becomes plus 6. Is that clear? That is the oxidation number of chromium in this compound, K2CrO4. Then the next thing we are told to do is to write the IUPAC name of K2CrO4. The name goes this way: potassium tetraoxochromate 6. The IUPAC name is going to be potassium. Tetra means 4 atoms of oxygen. Tetraoxochromate. The 6 will be written in Roman numeral form, enclosed in parentheses. So what is Roman numeral for 6? Is Vi. So the name of this compound, the IUPAC name of this inorganic compound is potassium tetraoxochromate 6. Is that clear? Do you have any question? Don't forget that we have example 2 on the board. What is the oxidation number? Example 2. What is the oxidation number of chlorine in KClO3? And then write the IUPAC name of KClO3. How are we going to approach that? We are going to repeat the same method that we have here. Okay? So we need our board eraser to erase. Okay? Okay, it seems you can solve over here. We'll start by saying, let the oxidation number of chlorine in KClO3, let it be Y. In the first problem we said let it be X. Now we're saying let it be Y. We have already established that the oxidation number of potassium is +1. So I'm going to take +1 here. Do we have 2 atoms of potassium? No. So I'm not multiplying it by 2. Then I'm going to say plus oxidation number of chlorine, which is the central element here, which is Y. We're assuming to be Y. Then plus, this is oxygen. We have agreed, we have explained that the oxidation number of oxygen in most compounds is -2. We have explained it in problem 1. So I'm going to write -2 times, how many atoms of oxygen do we have here? 3. Everything will be equal to 0. Remember, the net charge of compounds is 0. When you add all the oxidation numbers of all the elements in a compound, you are going to get 0. So let's continue. This is +1. This is plus Y. -2 times 3. -6. -6 times plus. We'll have -6. Equals 0. Are there like terms? Can you gather the like terms? The like terms are +1 and -6. So using the number line, +1 -6. What is it going to give you? -5. So we have Y -5 equals 0. Then you carry -5 over to the right hand side. You have Y equals +5. That is the oxidation number. That is the charge of chlorine in this inorganic compound, KClO3. What then is the IUPAC name of this inorganic compound? The IUPAC name can be written this way: potassium trioxo chlorate 5. Because we have the oxidation number of chlorine here to be 5, so we have potassium trioxo chlorate 5. Do you know why we say trioxo? Because there are 3 atoms of oxygen. Do you understand? Do you have any question to ask? Feel free to drop any question you have on the comment area, so that in our subsequent videos we'll look at whatever question you may have about IUPAC names of inorganic compounds. Do you understand? Thank you, students.